Hey everyone. Today we're going to be talking about the drawings for our depth gauge and just kind of like reviewing what I'm expecting of you and also going over like a few of the details that you might need a tiny bit of help with. So as far as our cover sheet is concerned, pretty basic. We of course have our isometric view, we have our callouts, we have our bill of materials, and we have our title and our accurate scale. You can go through and change the scale of your drawing, including this note down here, by double clicking on the sheets and then changing the scale to here. So like I could go to, let's say, a 2:1, and notice it changes the size. It also changes my scale down below. We also can see that honestly it's too big for that. So we're going to slide back up to 1:1 and we're going to leave it right there. As we move into sheet 2, we have our exploded view drawing, okay? And again, we have our bill of materials, we have our exploded view, which again should be arranged so that the base is at the bottom, and then these pieces build into it, and the screw comes in from the front. We have our part balloons, we also have our name and our proper scale. Now I want to show you really quick how to put this in again, so I'm going to delete that. I'm going to go to Inserts. I want to select my assembly. I want to select an isometric view of my assembly. And underneath Explode and Position, right now it's default. We want to go to our exploded view. So mine's called Explode 1. We can wait till that thing loads up. We can then drop our exploded view in, right? And again, we're going to show our shaded view. We're going to pull in our callouts, which my callouts have been changed now that I've changed things around. So I'm going to bump this back. So I'm going to say that I want it to be my part number. It's going to be a circle. You probably won't have to do that yet, but you might have to do that in the future. Oh, not that. Yeah, I really needed to turn on my item number. See, it has my name there. So now I can come through here, put in my item number. Delete this one. I can continue with that process as we go down. Drop 2 in, drop line 1 in, and finally drop part number 4 in. Okay, now we're moving on to our next sheet, which starts all of our part drawings. Okay, so sheet 1 is always going to be your cover sheet. Sheet 2 is going to be your exploded sheet. But as far as your part sheets are concerned, I really don't care what order they come in exactly. Alright, so I'm starting with my handle. So let's just start with that. The first thing that you're going to need to do for this drawing is you're going to need to change from inch units to metric units. Like we drew it in metric units already, but as you go to dimension, it's going to be dimensioning automatically in inches. So we need to change that first. So we're going to go to the drawing properties on the right. And currently your unit properties are going to be set to inches. Now you can see that everything has changed to standard dimensions. We want to change that from inches to millimeters so that we have the proper unit. Okay? So once we have that set, then we can start going through to set up our dimensions. And for this piece, because there's so many different parts, I have elected to use what is called baseline dimensioning, where all of my dimensions, especially in this view, land at the same point, which is the bottom of my piece. Baseline dimensioning is actually really great for manufacturing too. It's better than for manufacturing because you can measure off of the same point over and over again. So with that being said, you know, when I went through to dimension, I dimensioned from my lines over and I selected my 8.5. And again, it's important that you're selecting the right side of your line. So if I go to dimension and I select a line and a line, oops. Select the line and then this line here, it automatically puts a gap between my extension line and my object, which is great. If I were to dimension from like say a point across the board and then bring this over, you can see that there's no gap between here and here, which is not ideal. Okay, ideally we want gaps between our dimensions. So I would just delete that and I draw it again, you know, and I could totally select this edge to this edge, or that corner, and then drop it in at that point there. So I have my smallest dimension, which is 8.5 millimeters, my next dimension, which is 15, my next dimension to here, which is 35, and then finally my last dimension, my total height, which is 70. Notice that I did not dimension to my chamfer down here, and I did not directly dimension to my chamfer at the top, although I have put in a chamfer note, which I want to show you how to do that next. So the chamfer note is underneath of our dimension tool, and we're going to go to chamfer dimension. The first thing that we're going to select is the angle, and then the second thing we need to select is where that angle produces an acute angle. And we're going to select that line, right? So again, acute is when we're less than 90 degrees, and obtuse is when we're greater than 90 degrees. So when we look at this, we have an obtuse angle on the bottom here, and we have an acute angle at the top. So we want to select the other side of the acute angle. And now when we come in here and we drop this dimension in, it comes out at 1 millimeter by 45 degrees. So that's excellent. The other thing going on with this here, again, is you got to kind of look at this a little closely. You need to determine what holes we really need. So the innermost hole is that 3 millimeter hole. I've dimensioned that at the top. I've also dimensioned my 12.5 from the top. You can also see that I have neglected to add hidden lines in this view. Honestly, the hidden lines are kind of confusing in the top and in the bottom because there's just so much going on here. So I have elected to simplify my drawing by removing those particular hidden lines. I do have hidden lines going on in my front view, and we have a section view also, which we're about to be talking about. But my inner diameter is 3 millimeters. They'd also mentioned the fact that that was reams on the drawing, which you could add that, but you honestly don't have to either, but you certainly could. So we have 3 millimeters there with a 12.5 there. Now again, we want to avoid our chamfer because our chamfer node is up here. We don't need to redimension it again. So down below, you need to find your 5 millimeter hole, which is, the diameter of the bigger part here. You need to find the 12.5 millimeter exterior, which is the bigger part here. You need to find the 8 millimeter part, which is this part here. Again, we always want to dimension to the circular portion of a drawing. Makes things easier to understand later on. Then I created a section view, which again, sections are at the top, right here. I created a section view down the center of this object, which allowed it to be sliced in half. I added my center lines and center points everywhere, as a matter of fact. And here I elected not to do baseline dimensioning, but just dimensioning from the bigger portion, which again is like my 8 millimeter diameter, and then another dimension for my top 9 millimeter piece. So let's see here. Baseline dimension, chamfer note, circle, diameter, section view. Okay, so that covers all of the notes that I have for this one here. Again, title, scale, isometric view. Here we have our base. Okay, and as we start to look at this dimension again, my circles I'm dimensioning from the top. I'm not dimensioning them from the side. Here I do have all of my hidden lines on, and again I have a section line drawn down the center of my piece to produce a section on the right. So one thing that I do want to remind you folks about is the hole callout tool. So for internally threaded holes, we can use the hole callout tool. Again, externally threaded holes don't work out so well, but or externally threaded rods don't work out so well, but we can come up to the hole callout, and then we're going to grab the hole. And again, you should see these hidden lines around here because you have that threaded tapped hole there. And when we come down, we can drop this in place, right? And this says that my diameter is 0.42 millimeters, which again is the tap diameter of an M5 screw. That hole goes down 6 1/4 inches. Then my my thread call out is an M5 by 0.08. So again, when you look at this thing in your model, you're only going to see the interior dimension of this hole, but here in this drawing you see the exterior diameter of the hole too, which is that 5 millimeter M5 like external threaded hole. Again, I've added my section view, and of course everything else here. Alright, so I have my diameters for my holes, I have the distance to the center of my hole, I have the distance here. Here I've kind of broken up my length dimensions because when I dimensioned between here and the center of this object, you know, that dimension's like running straight through that 12.5, and I just didn't like that, so that's why I bumped that dimension up to my top view, going to the center there. I have my depth dimensions over here. I also have the depth of the holes in my section view. Okay. Moving on to the screw next. Screw's really basic. I have done a pretty big scale here because it's such a small part. I have my length dimensions, I have the overall diameter of the like thumb part that we actually turn, and then we need to create our own call out for the thread type, because again, external threads are not well done in Onshape. So in order to do that, we're going to grab our call out tool, and we're going to need to edit how this thing works. So we're going to get rid of table item number by deleting that, and we are going to type capital M5 by, which is an X.08. Okay, and that's going to reference our thread. We're going to turn off the circle. Now we're going to select this point and drop our thread notes on here. Don't put a thread note or a diameter here. This references what it should be moving forward. Okay, and again, isometric, title, scale. Again, if you want to change the scale of everything all at once, double click on sheet 5. And, you know, you could even bump this thing up to like a 4:1. And that's perfectly acceptable too. And again, that automatically changed the scale for me at the same time. Last but not least here, I have my rod. Certainly, it is the most easy drawing that you're going to do here. You bring in your rod, add your center line, your center point, dimension the height, dimension the diameter, put in your isometric view, name it, make sure that your scale is accurate, and that pretty much wraps up the sheets at that point, you know? So again, make sure that you have center lines, center points, make sure that your dimensions are easy to read, make sure that things are as clear as possible, that your dimensions are not overlapping one another, that they're all within your border lines, nothing should extend beyond your border lines. Make sure that they're in metric units, make sure all of your circles and cylinders have center points and center marks. Make sure that your scales are accurate, you know, and just double check your sheets before you turn them into me. All right? If you have any questions, you can talk to me or email me, and we'll go from there. All right? Okay, everybody. Good luck.